Good afternoon, good evening, wherever in the world you may be, or good morning. My name is Andrew Maguire, and I am product marketing at VMRay. And joining me today is Ben Abbott. He's with the technical field operations group, actually deploying our solutions in the field and working with customers and getting them up and running. So we're going to forego any introductions and hopefully get the ball rolling. So today we're going to talk a little bit about false positives and the effects that it has on, the SOC analysts, and also a little bit about EDRs and the challenges that they present from an operational perspective, as well as, the downsides of EDRs. Yes, they're great. I mean, if you look at where endpoint protection has come over the last couple of years, it's definitely been a value add in the technology stack, but there are also downsides to them with regards to analyst burnout and alert fatigue. The other thing that we're going to talk about is being able to calculate the cost of false positives and the effect that those false positives have on your organization. And then we're also going to be handing it over to Ben then to talk about how you can automate malware analysis with your EDR solutions. And then we're going to wrap it up. So moving on. So the upside and the downside of EDR and XDR deployments. I mean, legacy antivirus solutions have been out there for a while, but unfortunately, they're no longer reliable or robust enough to identify zero-day threats. As malware writers have basically learned how to circumvent these static engines by padding files with extra bytes or encrypting strings to blind detection, right? So heuristics, while good, is not great because they're only looking for known elements within that binary file to be able to raise a flag. And if a malware writer is writing code, they use something that is typically not used, and it can bypass that heuristic engine as well. And also there are new types of attacks, right? Such as fileless malware and using sort of living off the land tools, right? So they're basically using whitelisted native system tools like PowerShell to take over a system, and they're just not detectable. So yes, EDRs are better than the older static AV desktop solutions at detecting threats. And we've seen that, which is why a lot of MDR and MSSPs are wrapping their services around these solutions. But there is a downside and there is a cost. So if you are, one of the biggest trends right now is being able to outsource incident response to MDR service providers and managed service providers. And it's definitely gaining momentum, but many MDR service providers are limiting the types of vendor choices that they provide to customers. And that's for a very good reason, because one of the challenges of EDRs and XDR solutions, XDRs less so, is the ability to fine-tune them. Because they're not static-based engines, they're actually looking at behavioral anomalies on the system and also the user behavior as well. They're more prone to false positives. But the ability to understand the environment variables that affect the detection, they're able to quickly adjust the sensitivity to that customer's environment, right? They understand what those variables are and they can adjust them and reduce a lot of the false positives. And that's why these turnkey security tech stacks save a lot of customer time and money in the long run. And they provide overall better protection than a disparate any vendor solution. However, increased visibility also means increased data, increased analysis, and that requires more skilled analysts to address the increase in false positives. So the upside of automation is the ability to really integrate openly and exchange telemetry data with other solutions that may also provide collaborating evidence of attack. And that strengthening of the evidence actually helps reduce the dwell time of the attacker on the network. So that's the upside. And so let's look at the downside. So the downside really is, as we've said, false positives. But if you look at, there were a number of studies done around 2015, 2018, that the average number of hours wasted each week by an organization on false positives was around 395 hours. And the average cost was about $25,000 or about $1.2 million a year just on false positives. And the reason why these false positives are generated because of the behaviors is every time that you introduce a new application into the environment, or you do a software update, or you have abnormal user behavior, what it considers to be abnormal user behavior, you're going to get these false positives. You can, to a certain extent, reduce them by using preloaded application exceptions. And you can also group machines so that you can identify that behavior, and that will literally help reduce the false positives over time. But unfortunately, malware writers are also looking at, even though EDR and XDR solutions are way, way, way better than the traditional antivirus solutions, they are looking at ways to circumvent that technology. So there's some malware out there right now called Mockingjay, which evades EDR hooks, and it does DLL injection, hollowing processes, and also malware writers are using ChatGPT to generate code to evade EDR solutions as well. So there's a plus and a minus for them. They're not completely infallible. But if you are looking at an EDR solution, there is a project on GitHub right now, which is EDR telemetry project, which actually looks at all the different types of behaviors and the data that is collected by these EDR solutions to detect attacks. And if you're looking to sign up for one of those solutions, then that's probably one of the best places to start. So you have all these false positives being generated. And in some cases, it's in the thousands per day, especially in the case of MDRs and MSSPs, where they're managing hundreds and sometimes in the case of thousands of customer networks. So the challenge is, at the end of the day, analyst burnout, right? Too many EDR false positives. They're doing a lot of manual processes that get in the way of fast tracking a lot of these investigations. They don't have enough skilled people to be able to do it. And at the same time, they're also doing things like curating threat intelligence to be able to set up those defenses so they're not attacked in the first place. But at the end of the day, the main thing is being able to sorry, I've lost my train of thought then, being able to weed out all of these false positives and so that you're making all of the alerts actionable, right? Rather than giving a whole bunch of alerts and finding out that 25–30% of them are false positives, which has a negative impact on the analyst that's actually doing the work, because of it's a huge morale hit for them when you spend hours and hours figuring out whether this really is a malware attack or not. And at the end of the day, finding out, well, actually it was something else and it was completely benign. So being able to automate that process of false positive validation and weed out those alerts in the first place really goes a long way in helping these analysts, know that whatever they're working on at the end of the day will be something that they can mitigate. The other thing is that there are a lot of tools that are very disparate. They don't work together. They are actually slowing the process, the investigative process. And it's also about the inconsistency of data that's provided. If you have a bunch of analysts working on different threats, they will have different results if they're doing it manually. So automating this provides a lot more consistency in the threat data that they're providing back into the database, and also being able to coalesce alerts from other solutions to be able to enrich that data and at the end of the day, give a better visibility into actually what's happening. So there are some challenges with regards to, the analysts and the fact that they're working these 10-hour shifts, and it really does, at the end of the day, incur a mental debt to them. So that eventually leads to, as we know, analyst burnout and high turnover at the end of the day. So alert fatigue by the numbers, the average number of alerts for SOC teams is around about 11,000 alerts per day. And this is just from an enterprise perspective. So if you're an MSSP or an MDR service, you're going to have a whole bunch more, right? So there is no way that you can physically do this manually. And something like 67% of the IT teams actually ignore the alerts, the lower priority alerts. They either just completely ignore them, or they tune down the EDR solution so much that they're not actually emitting these alerts. And that's a problem, because it could be the foreclosure to eventually a full-blown attack. So every alert needs to be investigated, and if they're not being investigated, there's the potential for compromise. 25% is really the percentage of security alerts that are false positives. So that's the average. If you're a large enterprise, you can go as high as around about 43% of false positives. And if you're an MDR or an MSSP service provider, they can be as high as 54%. So that's a lot of time taken to figure out, yes, at the end of the day, you can whitelist and blacklist them, but false positives, and we have a slide coming up soon, can be activated by a number of different things. But so 10 hours per week on average, security analysts spend on responding to these false positive alerts. And at the end of the day, that's going to cost around $25,000, $26,000 per year. And that's at a rate of about $49 per hour. So if you're analysts are being paid more than that, it starts to get really expensive. So one of the things that we've done at VMRay is come up with a malware false positive cost calculator. And this is actually on our website right now. You can go up there and play with it. It's the URL is at the bottom of the screen there. So if you input the number of malware alerts per day, the percentage of false positives that you have, and most people have around about 25%, that's the industry standard, and also the number of SOC analysts that you had, the average cost per hour per analyst, and the average time to solve a malware alert, which can be in sometimes hours, or if not days in some cases, being able to put that average time slot in there, and it will give you a calculation roughly of, it's a ballpark figure of how much those false positives are going to cost you from a company perspective. Oh, so one of the things that we look at here at VMRay is economy of service. And economy of service really comes out of the MSSP and MDR space, but it also applies to enterprise SOCs as well. So if you have thousands of suspicious EDR alerts coming in, typically the thousands of alerts that you experience are not just malware alerts. Okay, there are going to be vulnerability scans, they're going to be firewall alerts, they're going to be intrusion detection and prevention alerts. But you could, if you narrow it down to exactly what the number of malware alerts that you have, right, you can to a certain extent filter out a large number of them through blacklisting and whitelisting, but there is always a handful that you have that you're going to have to either manually triage or you're going to have to use automation to figure out. And from our analysis, it typically takes something like 30 tier 1 or tier 2 analysts around about 150 hours to triage 100 alerts. Whereas if you have a single tier 1 analyst using an automated solution, he can do the same he can basically do the same amount of alerts in the same time frame. The value that you get at the end of the day, though, is more consistent results. They're more the data that you get back from automation is going to be more consistent, and you're going to have fewer false positives in there at the end of the day. So once you've implemented an alert validation into your SOC processes, there will be initially a drastic reduction in the false positives, but that's not it at the end of the day. It really takes consistent tuning as your ecosystem changes. You roll out new applications, you have OS updates, you do driver updates, and actually drivers are one of the biggest problems when it comes to false positives. But it really is sort of a constant tuning and managing down the number of false positives that you get within the organization. And if you're doing this manually, it's a nightmare. So at the end of the day, you have to automate it. And at this point, this is where I'm going to hand it over to Ben, who's going to talk about how the best way to do that is. Ben, over to you.
Yep. Thanks, Andrew. So in reality, what we're doing at VMRay is really complementing any existing tools and processes that you have in place. So we're not here to replace any existing XDR, EDR tools that you have. What we're doing is working with those tools to help filter out what your team really needs to spend time investigating and fixing from there. And so there's a couple different ways that you can automate that within the process you have. So whether that's a direct integration, what we have in place here, so with an existing connector, so you don't need to install any additional agents on your system, you can just use the existing EDR agent that you have. That will trigger alerts and go to their their central solution, whether that's within the cloud or whether it's on a server on site. Those alerts can then trigger the integration that we've set up from here to then grab the file that triggered that alert from that endpoint system and then send that over to our VMRay sandboxing tool. So we're actually able to detonate that solution and then get the full behavior analysis of this. And that can provide a couple different insights to it. One, if we can, since it's behavior based, it can tell you if this is truly something that should have triggered an alert within the system. So if it's a false positive, it's not triggering any known malicious behaviors or suspicious behaviors on the system, you know that you don't need to spend as much time looking into that tool, and you can work on fine-tuning the existing EDR solutions so that alert doesn't come up in the future. But also it can help enrich some of the data for the true positives as well. So in addition into just letting you know that this is a malicious sample, and you do need to quarantine this. It can also trigger and generate IOCs that are helpful for finding any additional systems where this may be in place, but also help enrich the data for those EDR tools so they can find this better in the future as well. And so this can be done, again, with the more direct integration that we have here. And there's other ways that we can tie into that and other triggers, such as blind spot detection. So if instead of just a trigger for malicious, if it's just unknown, you don't know whether or not something should you allow in your system, we can then run that on ours, and if we do find malicious behavior, say this is actually something you should quarantine. So it's really there to augment and complement any existing teams. There also is leveraging any SOAR tools. So obviously, this is sort of the point of any SOAR solution, is to integrate multiple tools across the board. So that way, it's not only coming from EDR. Maybe you have tickets and alerts coming in from multiple tools. Maybe also like your SEGs. Anything else that may be coming through, and you also want to investigate any files URLs coming from those tools. So this can be an additional way to filter out all those alerts and funnel them into our tool to again validate that those alerts are something that need to be blocked or quarantined, but also if there's anything that maybe you can allow, and have your team make that determination based off all the information that we provide within the reporting. And so from there, that's what we'll go into a demonstration, and there's a few different pieces I'll get into at this point. So just in terms of the demonstration itself and what we'll be showing, we're going to be going through the integration we have with Sentinel-1, and although it's the video that we'll show is specific to the Sentinel-1 integration, overall that process is going to be the same regardless of what solution that they're using at the endpoint. Really, all we're doing from here, and we do have a GitHub for all of these that go into what the integration will do and how to set that up. But it's really just looking to, again, for the file that's submitted from that endpoint, we're able to then get the overall classification, so whether it's malicious, suspicious, clean, but also any behaviors, or we call our threat identifiers within that tool, and also IOCs. And all the information is then passed back into that tool. And so you'll see that process play out within the video, and also the different ways that you have to set this up, whether it's you have just a server that's running it, or just like a Docker that you have running. And that's what we're showing there within the video itself, again, to show you all the various logs that are coming through so that you can see that in place. Within the VMRay tool, and you'll see this from the automation dashboard, there's a few different ways that you can implement these. So with the API key, so whether it's a SOAR tool or some of the EDR solutions, and going to integrate that. When those do come in place, you'll have different layers within the report that you can look at. And so this is an example of one. And you can see here that beyond just the dynamic analysis that we do pass through, we do have other checks on this file before it gets to the dynamic analysis. So you can use this actually to triage it, and this could depend on each individual use case that you may have. For things like reputation static analysis, if we already see that it's malicious here, whether it's just the hash value for the reputation or for the static value, in addition to hash values, it can also get some additional context of the file. Maybe there's YARA rules. Maybe if it's, if they're still seeing like macros on that system, we can see that if it's trying to trick users into use that. So there's a lot that we can get just from those two pretty instantaneously. So if you're looking for maybe the fastest response to those alerts, you can have those triage to filter out both known malicious and benign samples based off the reputation and static. But we also have the more in-depth dynamic analysis, and this we're actually, again, detonating that solution within our environment. So that way we have the full behavior of this. And that's what you're seeing below here in these VMRay threat identifiers. So we have known malicious and suspicious behaviors that triggered from that detonation. And this is what we're using to calculate whether or not that, the overall verdict of that analysis, and again, the overall verdict for the sample itself. And so it makes it very easy for even the lowest level analysts to understand exactly what's happening. And even for something like this, where we can see the particular malware family, what they could do some research on this just based off here, and be able to see what that might need to accomplish to address this. We also can give feedback on the IOCs, and this is one thing that we do. It's unique to us that kind of notorious for sandbox solutions to have a ton of IOCs that are passed from this. And even if you weren't to push all of them through, then you have to sift through those artifacts to find out what's relevant to the malware, and then that can also then compound the problem if you're putting all that information in. And if it's not relevant to the actual behavior of the malware, it can then trigger more false positives that your team's looking into. So what we've done is actually used to filter out which of these artifacts are relevant to that behavior. And so you can grab all of those artifacts, so you can filter to see all of those. But you can see here, whether it's some of the files or URLs or even the processes, the IPs, they'll have all related VTIs to these. And so you can go between each of these and see what those might be. It could just be that, and here from the actual configuration of the malware, we're able to extract out some of these URLs. So this, again, much more relevant to what you may want to pull out of there from any other threat enriching that you may have in the system to help block these in the future. And so all of that information can be really relevant. And so it's much easier to pass off, say, 14 IOCs as opposed to 250 artifacts that we have from there. The other example, and this is actually more on the blind spot detection side, and here we do classify it as malicious, and there's a lot of different classifications, and we can even get particular malware families that are tied to this. And so even though this is a known malware family, we see that the reputation static analysis actually didn't detect this to be malicious. And so this is something that could potentially bypass the EDR solutions as well, because there's similar technologies that are using both the reputation and static here. But because we're able to actually detonate the sample within that live environment and then see the behavior of it, and we're not reliant on any known malicious context already, what we can see is that there is a number of different malicious behaviors that are tied to this, even without getting into some of the known malicious content for things like extracted configuration and YAR matching and some of the reputation that we see from there. So although we have a lot of details that have a known malicious content, there's a number of this that's actually just based off the behavior itself, whether it's things like the injection that takes place, even things like the data collection, where this is actually more of an aggregate rule set based off all of the other data collection and discovery that takes place from here. So because there's a number of instances of this is where we can classify this as spyware, and just that on its own, we can have it, but then also get more direct malware family and extract configuration, and also get some of those details over for the IOC. So a lot of that detail that we can get from this. And this is why it's important to kind of use this as a complement, so that you can, whether it's unknown samples that maybe that EDR solution maybe didn't trigger an alert, but you want to then actually still send those over to confirm whether or not that's something that you do need to quarantine on the system. But also, again, on the other end of it, if you do for any of the triggered alerts, to make sure that we are able to confirm that this is indeed a malicious sample, and that can go through. And then the other side, if it's not confirmed with the detonation, then that it's something that your team can have a much better insight into actually what's happening with that sample without going through the trouble of detonating their own, as they can look through some of the more detailed reports where we have for the dynamic analysis reports, and be able to get that information from there. And so all of those details, whether it's screenshots, whether it's process graphs, everything, all of those details here are within this detailed information. So they have a lot of information disposable. So even the lowest level analysts can help better understand this. But also, as it goes up through the process of someone making a determination, there's less repeated processes that need to happen for each stage of that. So that the level 2 isn't repeating the same thing that happened at level 1, level 3, so on. So we can have all of that information here. And now for maybe the more interesting part, here we can play this just quick video. And this is just the Sentinel-1 integration in place. And again, it's really just going through the Docker to start. And so this way, what we can see from here is then what we're doing is we're just running this malicious sample, and we have the Sentinel-1 in place. So when we do run it, we can see it's being blocked by Sentinel-1 here. So there's nothing out of the ordinary for right now that we're seeing for this is all blocking. But then how we see, then what we want to show is how we work in tandem with this. And so when you go to the Sentinel incidents and you following along with what's happened here you can see that sample getting picked up. It's being triggered an alert, and then you can see from the Docker logs everything that's happening from there. So it searches to see if it searches to see really if this is already within the database. So it's not just rerunning submissions that have already happened. And then it says that it does need to download it and submit it to VMRay, and then it goes through that process to actually submit that to our tool. And when you go to then the dashboard of this, that's when you see that a few seconds ago, we have that sample that's been submitted. You can go into that particular sample and you can see that it's currently running. We see the dynamic execution happening from there. And what's nice about our tool is you can actually see that detonation occurring live. And you could even choose to interact with this if you wanted to, but if you're for the purpose of this, we're sort of ending this after it's done. But again, what's helpful is you're actually able to see that detonation happen live. And then from there, you get the full analysis report that occurred from there. And again, it's very similar. We have the red line malware that we see from this. So we have all that details are just at our disposal. So again, confirm that this is indeed malicious. And then on top of that, and get any IOCs that are related to that. And so then that information can then be passed back into Sentinel-1. So then once that detonation is completed, then you can go into that incident, and you can see here what we've provided. So we have we have the SHA, so we have the hash value, we have the analysis verdict. So we can confirm it's malicious all right there. So that can be pretty simple. We have a link back to the sample, so you can go within VMRay and go and see exactly where that sample is. But then you're not searching within our tool to find it. You have that link right there, where then your team can investigate it, classifications, but also the threat name. So again, you can see even you can just see that red line stealer, you can see that from there. You could do any research and obviously quarantine that system, but then you have the related VTIs or hash values for the IOCs or domains or IPs that you might need to block as well. So all of that information is right here within the Sentinel interface. You don't even need to go into VMRay to do that, because all of that's happening in the background. But you still have our tool to help complement any investigations that may occur from there. And so with that, I'm going to just go back to the presentation and pass it back to Andrew here.
So let's talk a little bit about integrations, because obviously integrations are really key when it comes to automation. And one of the things that we're working on right now is so each one of these has a connector that allows us to import our analysis into each of these tickets and the databases of all these solutions. And one of the ones that we're adding right now is CrowdStrike, which should be available in, I think it's in the next week or so, or even a few days. So we're actually going through testing and validation with it. And so if you do have a CrowdStrike deployment, now you can replace your Falcon sandbox with VMRay, and which is one of the challenges with CrowdStrike is that it's a hooking based. They say that it's a kernel mode sandbox, but actually it's a hooking based sandbox as we know it, and they have limitations where malware, especially when it's very evasive malware, is looking for indicators within the environment to detect whether it's in a monitoring environment or not, like a sandbox. And we've done some analysis on CrowdStrike, and there are something like 60 plus evasion indicators that can be detected by malware and malware riders to identify that it's in a sandbox environment and basically shut down the payload deployment of that sample so that it doesn't detonate, and literally leads that person to either think that the malware analysis is stalled or it's a partial detonation, and they're not getting the full information of that sample. So there are definitely, because VMRay is hypervisor based, we don't have that problem. We don't have any agents within the monitoring environment to be able to detect. And so therefore we get typically 100% detonation every time. So with that, so we have, just very quickly from a high level, we have 3 solutions now within our product portfolio. Deep Response is the for manual submissions with full reporting. Final Verdict is the automated, where we can do malware triage and enrichment and EDR alert validation. And then Total Insight is more of our threat intelligence extraction, being able to do things like assist you with the threat hunting and generating data to embellish your threat repositories. And then so just to wrap it up. So yes, I mean, EDRs, they're a great solution. Unfortunately, they generate a lot of false positives. You need to be able to manage down those false positives. A lot of organizations don't have the skilled resources to be able to really fine tune them. And if you do have an EDR deployment and you're getting less than 4% false positives, you're doing great. But a lot of organizations aren't, and they're struggling with it. And this isn't just vendor hype. If you go out there and look on the internet at all the forums, it really is a struggle. So in that way, VMRay helps you to address that issue and lower the cost of your false positive issues that you have. So, and then being able to automate either via EDR or SOAR, you get faster responses. You'll be able to accelerate the investigation process of malware samples and the triage of such. But the other thing, I think around about 60+% of our submissions are really all around phishing emails. So there's a lot of challenges around that. So we have what we call an abuse mailbox that allows you to forward potentially suspect phishing emails that have circumvented your point solutions, your point phishing solutions, or your point email security solutions, because they are static. To be able to educate the user base and use them as an extension of your detection mechanism. And when they see a potentially suspicious email, they can actually forward it to the abuse mailbox, circumventing the SOC team. So they're not involved, and it automatically does analysis on that phishing email, any attachments, and then sends a response to that user saying, yes, this was potentially malicious. And oh, by the way, we're also going to inform the SOC team and let them know so that they can start putting those controls in place to block them further. So that said, Ben, anything further from you?
No, nothing else for me to add.
All right. So anyway, thanks everybody for joining us today. We really appreciate the fact that you took the time. If you have any questions, if you'd like to submit them via the chat, we're happy to see if we can answer them for you. And I think there is a QA question here.
Yes, so there is one around integration with ServiceNow. So it is something that we've looked into. It is partially, it's hard because one, they're even just to have an integration list on their site, they actually make you pay to have that up there at all. So that's one difficult piece that we've run into. But we do have customers that have created their own integration directly with that. So beyond the connectors that we have out of the box already, we do have an open API, so you are able to customize any existing integration that you may have. It could be with something ServiceNow or maybe an additional ticketing system that you may have in place. So like some customers even use like Jira, for instance, for their ticketing, and have integrated our tool with that. And so there's a number of ways you could do that, and we can certainly help with that, setup and implementation.
So the other question is that I have was from an integration standpoint, and actually setting up the integration with something like SentinelOne or CrowdStrike, for example. How easy is it to do that?
It's relatively straightforward. So really what you need is just a really lightweight Linux box that is then connected both to our tool and to the to that cloud solution, or to that the server that you have in place that's running the EDR. So whether it's something like SentinelOne, or whether it's Carbon Black or CrowdStrike, whatever it might be, all it's needed is running there, so that any alerts that are coming can be directed or found by that server, and then all of those alerts, then that will then trigger the rest of the integration to then grab the related file, send that over to VMRay, and then pass those results back into the endpoint solution tool.
So it's really as simple as generating an API key at the end of the day.
Yes. Yeah.
And you can be up and running within hours or minutes?
Yeah, definitely. Yeah, within within the hour. I mean, it's all explained on the GitHub of exactly how to set that up, but it's pretty simple to set up.
Great. All right. Unless we have any more final questions, I think we're going to call it a day. And I think we're good to go. All right, Ben, thanks very much for sharing. And thank you all for joining, and we hope to see you again sometime soon.